Okay, in this lecture, I'm going to go over how to use some resources to be able to go through the practice exam. And there's a new resource that I put together that I just want to show you how to use. And so I'm just going to go ahead and share my screen with you. And let's see here, dashboard. Okay, so with this resource, um, I am going to come right in here. And if you haven't downloaded it yet, it's should be on the Unit 3 workbook or under announcements. If you go to announcements, here's a resource and it's called Calculating Z-Values and Probabilities Worksheet. Um, and so I've got that downloaded right here. Okay. Um, And so a lot of your questions that you have, you will actually be able to use this. And so for almost all of your questions, you are either using this uh, worksheet right here, or the other possible worksheet that you're going to use is the decision tree worksheet. Okay, so just make sure that you're using both of those. And we're going to go to the practice exam. Okay. Um, and so let's go home. And we're going to go to 332. And there are some questions that you can review in there as well, but let's do 332 practice exam, specifically over some stuff that I know that you guys struggled with. Okay, three of these statements are not true about sampling distributions, but one is true. Let's see here. Let's come down here. Oh, yeah. An experiment involves selecting a random sample of 256 middle managers for the study. One item of interest is their annual income. Okay, so let's look at this. Um, a sample mean is computed to be 35,420 if the population standard deviation is 2050. What is the standard error? Okay, so first of all, am I calculating a confidence interval? Um, and the answer is I don't think so. Nope, we're not calculating a confidence interval at all. We're not calculating a sample size. And so the one that I'm going to be using very specifically is I'm calculating the probability of getting a sample of a particular at a particular value, or getting a sample with a particular mean. So if you're calculating a sample with a particular mean compared to the population mean, we're going to do this right down here. So first of all, the sample mean is computed to be 35,420. So I'm going to come right in here and I'm going to do, first of all, 256 is the sample size. Okay. The standard deviation is 2050. Okay. The mean is 35,420. And then the population mean is 35,620. And now I'm going to get the sampling error. The sampling error is simply equals the sample mean minus the population mean. And this is definitely wrong because it's supposed to say have a zero at the end. And so the sampling error is negative 200. And now we're going to calculate the standard error. So right here it says, what is the standard error? And it simply equals the standard deviation divided by the square root of the sample size. Okay. So, and that's 128.125. Okay, so 128.125. If the population mean is 35,620, what is the sampling error? Okay, so if the population mean is 35,620, what is the sampling error? Let's do this exact same thing. Control C, put this right here. And so 35,620. Oh, sorry, if the population mean. Oh, whoops. So 35,620. What is the sampling error? The sampling error is negative 200, which is right there. What is the probability of randomly getting a sample mean of 35,420 or greater compared to the population mean of 35,620? Okay, and so first thing that we've got to do is calculate the z-score, which is literally just the sampling error divided by the standard error. Okay, and so that gives you your z-score. And now we've got our z-score and we're saying, hey, let's compare this z-score, or let's determine the probability of getting this z-score. Okay, and so you've got this fun little distribution, this normal distribution. And if I get a z-score of negative 1.56, it's going to be somewhere like right here, negative 1.56. And so what's the probability of getting that that observation, this outcome? What is the probability of this with a sample of this? What's that probability compared to the population mean of 35,620, or getting greater? So we're going to come right here, and this is the probability below. So equals norm dot s dot dist, the z-score, true. And that gives you the probability of it being below. Okay. And then we're going to get the probability of it being above, and we're just going to do equals 1 minus the probability of it being below, which gives you 0.941, if you will. The probability of randomly getting a sample mean between 35,420 and 35,820. So we're going to do the exact same thing, Control C, Control V. Only difference is we're changing the sample mean. So we've got the first one, 35,420. The second one is 35,820. Okay. And so now we have the probability of getting below 35,820 and the probability of getting below 35,420. Okay, so what is the probability of getting between, essentially, right here, like right here to right here ish? Well, I don't like it. Yeah, right there to right there ish. What's the probability of getting in between there? Okay, and so the way that you do this is you take equals ABS, the probability of A minus the probability of B, and it gives you the probability of between the two of them. So the probability below minus the probability below, and it gives you the probability between, and so it's going to give you that value right there. Okay. Let's look at this. The wildlife department has been feeding a special food to rainbow trout fingerlings in a pond. Based on a large number of observations, the distribution of trout weights is normally distributed with a mean of 402.7 grams and a standard deviation of 8.8 grams. What is the probability that the mean weight of sample of 40 trout exceeds 405.3 grams? So first of all, once again, are we looking at the are we looking for the probability of something? Yes. We're not looking for a confidence interval. We're not looking for a sample size. We're looking for the probability of an occurrence. So the probability of an occurrence, we're going to use this. And so the sample size is 40. The standard deviation is 8.8. The sample size, or the sample mean, is 405, 405.5. The population mean is 402.7. And then we have the sample error, sampling error. Okay. And then the standard error equals standard deviation divided by square root of n. Okay. And then the z-score is going to be equals sampling error divided by the standard error. And then the probability below. What's the probability below? What's the probability that the mean weight exceeds 405.5 grams? So equals norm dot s dot dist true. And that gives you the probability below. So now we're going to do equals 1 minus this to give you the probability of above. Okay, so this is the probability of it being above. And so let's see here. Probability of it being above, right there. Bada bing, bada boom. Okay. Mileage tests were conducted on a randomly selected sample of 100 newly developed tires. The sample mean tread was 50,000 miles with a population standard deviation of 3,500 miles. What is the best estimate average tread life in miles for the entire population of these tires? So we have a sample of 100. We got a mean of 500. And so the best guess estimate is 50,000. The best guess estimate is whatever we have from the sample. This, in other words, I'm not going to tell you the answer, but I'm just going to tell you that you're going to use the point estimate from the sample to give you the best estimate for the population. Okay. The point estimate from the sample to give you the best estimate for the population. Let's see. This right here, the mean number of travel days per year for a salesperson employed by 3 hardware distributors needs to be estimated with a 0.9 degree of confidence. For a SMI-pilot study, the mean was 150 days with a standard deviation of 14 days. The population mean is estimated within 2 days. How many salespeople should be sampled? So we're looking for how many should be sampled. The mean was 150 days. Okay. So how many should be sampled for calculating a mean? And let's see here. Yeah, how many should be sampled? So we're going to come right here. And we are going to calculate the standard deviation. (14 days). And then the z-score for 90, it's going to be 1.645. And just in case you ever forget, it's going to be right down here, 1.645. Okay. The maximum allowable error is going to be 2 days. Okay. And then we are going to calculate the needed sample size. We're going to do equals, parentheses, the z-score multiplied by the standard deviation. Oops. Oops. Let's try this again. The z-score multiplied by the standard deviation. Okay. Divided by the maximum allowable error. And then we've got to square it. And so after you do all of that, it tells you the total number that you should sample. And so I really should have given you the option of 132, but the correct answer is 133 because you always need to round up. Always need to round up, so that's the sample size that you need. And right here it says how many salespeople should be sampled. Okay. A survey of urban university population 25,420 showed that 870 out of 1,100 student samples supported fee increases. Okay. To fund the improvement of the sample center. But once again, first thing that you need to do, ask yourself, what is this question asking? Using a 95% level of confidence, what is the lower limit of the confidence interval for the proportion of students supporting the fee increase? Okay, so we want the lower limit of the confidence interval. So we're doing a confidence interval around a proportion because you've got a proportion of 870 out of 1,100. Okay, so we're looking for a confidence interval, so or margin of error. So the number of successes is going to be 870. The sample size is going to be 1,100. The proportion is going to be equals to 870. Okay, the z-score right here, we've got 95% level of confidence. So it's going to be 1.96. Okay, and then the error, the margin of error is going to be equals the z-score multiplied by square root of the proportion multiplied by 1 minus the proportion. And let's see here, divided by n. So divided by the sample size. And so right there, you've got your margin of error. And now we're going to take the proportion equals the proportion plus the margin of error. And then we're going to do equals the proportion minus the margin of error to get you your lower limit. Okay, so what is the lower limit for the confidence interval, the proportion of the students? Okay, so it's going to be 0.767 is what it is. Okay. And then let's see here. A group of stats students decided to conduct a survey at the university to estimate the average mean amount of students spent time studying per week. They sampled 554 students and found a mean of 22.3 hours per week, assuming the population standard deviation of 6 hours and using a level of confidence of 0.95. Answer the following. Okay, first of all, you've got a mean right here, and you've got a population standard deviation. And so I'm going to come over here and find the confidence interval around that point estimate. Okay, do I know the standard? So I'm looking at confidence interval around a mean. I'm looking for the margin of error, not the needed sample size. And I know the population standard deviation. Okay, so right here, we've got the mean. Okay, 22.3. Okay, 554 students sampled. The z-score 1.96. The standard deviation 6. Okay, and so we've got the standard error, which is the standard deviation divided by square root of the sample size. Okay, so that right there is your standard error. And now we're going to calculate 1.96 multiplied by the standard error, which gives you the margin of error. Okay, and then the upper limit, so equals the mean plus the margin of error, and then equals the mean minus the margin of error. And so we've got your confidence intervals right there. So the z-score is going to be 1.96. Okay, the margin of error is going to be 0.499. Hold on. Did I do something wrong? Okay, so we've got 1.96 multiplied by the standard error. Oh, it's just rounded. There we go, 0.50. Lower limit is going to be 21.8. There we go. Then the upper limit is going to be 22.8. There we go. So we've got all of those based off of this right here. Once again, I went through the decision tree, figured out what I needed to do, and that's what I did. So a random sample of 42 college student graduates revealed that they worked an average of 5.5 years in the job before being promoted. The sample standard deviation was 1.1 years using the 99.99 degrees of confidence. What is the lower and upper limits of the confidence interval for the population mean? So once again, step one, confidence interval around a mean or around a proportion. Let's see here. It's around a mean. Okay. Am I looking for the needed sample size or the margin of error? And I'm looking for the confidence interval or the margin of error. And then do I know the population standard deviation or is it unknown? And the answer is it's not known. So all that I have is the sample standard deviation. And so I've got equals, let's see, the mean, 5.5. Okay. The number 42, the degrees of freedom 41, and then for here I'm going to do equals t dot inverse dot 2t. The probability is 0.01 because it's the the complement to the 0.99, and then the degrees of freedom is right here. Whoops. Okay, so that gives me my t-score, and then my sample standard deviation is 1.1. And then we've got the standard error, which is going to be divided by the square root of n. Okay. And then equals the t-score multiplied by the standard error. And then the upper and lower equals the upper. And then equals the lower. 5.04 to 5.96. Okay. And then a group of stats students decided to conduct a survey at their university to find the average amount of time students spend studying per week, assuming a population standard deviation of 6 hours. What is the required sample size if the error should be less than half an hour with a 95% confidence interval? Okay, so what we're doing is, what is the required sample size? Okay, and we're looking for it around a mean. Okay, so step one, is it confidence interval around a mean or around a proportion? It's around a mean. And then we're looking for the needed sample size. And so we're going to come down here, the standard deviation of 6 with the z-score of 1.96, the maximum allowable error of, let's see here, should be 0.5. Yes, because you're dealing with half and one whole, so 0.5. And then the sample size is going to be equals z multiplied by the standard deviation divided by the maximum allowable error, and then we need to square it. So it's going to be 554 because you need to round that up. And so that's how you do all the calculations. The very first thing that you need to ask yourself is, what is the question actually asking? If it's asking for the probability of what's the probability of getting this value or something higher or something less, you're going to go to this sheet right here. So the probability of something higher or something less, or the probability between. If you are looking at confidence intervals, margins of error, so on and so forth, you are going to use this worksheet right here. So that's how you do that. And yeah.